Okay, excellent. So with the manifold construction done, we can now jump into the most exciting part of the talk, and that is the instanton construction. And just as we glued together two G2 structures for the construction of the G2 structure, we will now glue together two G2 instantons for the construction of the final G2 instanton. So to this end, let theta be a flat connection on T7 mod alpha. We've seen before that flat connections are particular examples of G2 instantons, because when the curvature is 0, definitely satisfies the equation that curvature wedge something equals to 0. So that's one thing that we need, and the other thing that we need is an ASD instanton on Iguchi-Hansen space. So let A be an ASD instanton on Iguchi-Hansen space. Then, as we've seen, P star A is a G2 instanton on T3 times pi inverse of T minus 1 B4 mod plus minus 1. So in pictures, we have our smooth manifold NT, which is the result of this complicated gluing construction here, with the G2 structure phi twiddle T. That's the torsion-free G2 structure. And here we had this green set that had been glued in. And to remind ourselves, so what do we have? Well, away from the gluing region, we had that phi twiddle is approximately equal to phi 0, and theta is a G2 instanton with respect to phi 0. And now on the green set, what do we have? Well, there we have that phi twiddle is approximately equal to phi product, and P star A is a G2 instanton with respect to phi product. So what we can do is we can interpolate between theta and P star A to get a connection, say AT on our manifold NT. Now this AT is not going to be a G2 instanton, because this time we made two kinds of errors. The first error that we made is the same that we made in the case of G2 structures. Namely, theta may be a literal G2 instanton with phi 0 with respect to phi 0, and P star A may be a literal G2 instanton with respect to phi product. But when we interpolate it in the middle, there is not going to be a G2 instanton. It may be close to a G2 instanton, but this is the first error we made. And the second error we made is that actually our G2 structure phi t twiddle is not exactly equal to phi 0 or phi product. It's pretty close, but not exactly equal. So that's the second kind of error that we made. However, the theorem of Walpusky then guarantees that there exists a G2 instanton, say AT twiddle, with respect to phi t twiddle close to theta and p star a for small t. And again, the meaning of close to theta and p star a could be made very precise, but it takes a while to really define that, so that's why I decided not to bother. And the proof idea is extremely easy to explain now, because it's the same idea as in Joyce's proof for the existence of torsion-free G2 structure. So we have that AT is an approximate G2 instanton, in the sense that FAT wedge star phi t twiddle, well, it's not going to be 0. If it was literally 0, then you would have found your G2 instanton, because that's the definition of G2 instanton. But it turns out, well, if you choose the right norm, that this is bounded by some constant times t to the 1/2. So that means, again, if you choose just a very, very, very small t, this thing becomes as small as you want. So you can make it as close to being a G2 instanton as you wish. And again, like in the previous proof, I will sum up pages and pages of hard work with one arrow. I would say elliptic analysis. But the end result is the same. The end result is that for small t, there exists an AT such that AT twiddle, defined to be capital AT plus little at, is a G2 instanton. So it satisfies that FAT twiddle wedge star phi t twiddle equals to 0. And that would be the end of that proof. Some details I did leave out is these gluing ingredients theta and p star a, they do need to satisfy some compatibility condition, but rest assured there do exist examples where these conditions are satisfied, and then all this analysis actually makes sense and you can produce genuine examples of G2 instantons using this gluing theorem. Alright, so now that we've seen our first example of a G2 instanton on a compact G2 manifold, let's talk about how this can be generalized. And There are just two generalizations that I want to mention. And the first one is generalizing P star A. So remember, P star A, that's a connection over T3 times pi inverse T minus 1 B4 mod plus minus 1. And, well, because we just pulled it back, is constant along the T3 direction. Now, what you could do alternatively is for each point in T3, you can choose an AST instanton, say AX on Iguchi-Hansen space, and then if you put them all together, this gives you some connection bold A. So that's the family of connections AX, where X is in T3. You can view that as a connection over, well, T3 times pi inverse T minus 1 B4 mod plus minus 1. Now, previously we had the luck that P star A was literally a G2 instanton. Now, if you choose some really horrible family of AST instantons, it's not going to be true that this thing is going to be a G2 instanton. So this is not exactly a G2 instanton. But it turns out if A satisfies a PDE just on T3, then the perturbation result remains true. So this partial differential equation on T3 is called the Fueta equation. And the nice thing is you don't have to check the full G2 instanton equation for your bold A, but it's just a PDE on this 3 manifold. So there are some examples of solutions to this equation. Right, so that is the first generalization. And another thing you could try is to generalize the underlying G2 manifold. So we want to generalize the manifold construction. So the point is, well, instead of the very special situation T7 mod alpha, allow any G2 manifold M and G2 involution or let's call it alpha, from M to M. And then everything carries over to M mod alpha. And again, the way I've written it, it makes it seem that all you have to do is replace all the T7s by all the M's. But it turns out actually that's much harder than this. Already the manifold construction so resolving the fixed point set of alpha in this case, that's a very hard thing to do. That was done by Joyce and Karigiannis in 2017. And the G2 instanton construction on these new manifolds, that was done by me in my thesis 2022. Okay, so to sum up, you've seen what are G2 instantons, we've constructed a compact G2 manifold, and we've constructed a G2 instanton on this compact G2 manifold. So I hope you enjoyed the lecture, and thank you very much for listening.